Hello friends, in this video we are going to see the different levels of our teaching learning experience with our students in online classroom as well as in offline classrooms. So the important point that we are discussing here is that the cycle of learning completes with assessment. So it starts with learning, then we have practice, and in the end we have assessment. So through this digital content of destination success, I'm taking you through a topic of geometry for grade 5 to show you all the three stages of teaching and learning for students. I'm clicking at my module of geometry and I'm opening my triangle video. These are the concept based videos that we have given in Destination Success. So the first page you see here is the learning objectives. My grade 5 students should know what they are going to do in the entire week. So through my learning objectives slide, I'm telling to my students what they are going to learn and how we are going to engage our students. We are also telling them that these are the important key words that they will be learning in this 1 week session of on triangles. So let's continue with the content.
We had better watch the weather, Dij. It can get very stormy out here in this part of the Atlantic.
The region of the Atlantic Ocean between Miami, Florida, the island of Bermuda, and San Juan, Puerto Rico, is sometimes called the Bermuda Triangle. Your mission is to explore triangles.
Bermuda Triangle? Bermuda is right here. But where is this triangle?
So in this video you have just seen that we have started the teaching of the concept. So we are at the learning stage for our students. The National Curriculum Framework tells us to start the topic from known facts to the unknown facts. Use real life example. So here what you see here, we have taken a real life example of Bermuda Triangle. It is also an integration of geography subjects with maths.
Good idea, Dij. If we let this point represent Bermuda and this point represent Miami, we can draw this segment between them. And look, Dij, if we let this point represent San Juan, we can draw another line segment.
Did you notice the vocabulary used here? We have used points and lines. That's a prerequisite to teaching of triangles. So we assume our child knows from our previous sections, from our previous class topics about points and lines. So we are using from known concept to unknown concept.
Since these segments have a common end point, they form an angle. Great! Well, we do know about angles, Dij, so maybe that's a good place to start.
Did you notice the progression? From simpler to complex. We started with point and line and then we added angle. Now from here we are going to do the actual concept of triangles.
Which of the following do you think are always true about an angle?
Learning to take place means we have to engage the child. We cannot play a digital module without the interactivities. So we have lot of interactivities into our destination success content. So in between, I will do a chunk of information sharing with my student and then I will ask the questions. Now this is the questions that my student have to answer. I can just tell them if I'm doing an online teaching, I can tell them to unmute and give me the answer. If it is an offline teaching in the classroom scenario, I can make my child to just come over the board and click onto the right answer. So I'm just clicking here and then I'm clicking on done.
Actually, these statements are true.
That's correct, Dij. The sides of an angle are two segments or rays that share a common endpoint. And we also know that angles are measured in degrees. You know, Digit, this part of the word triangle comes from the Greek word trias, meaning three. So, I wonder, triangle, three angles? But we have only drawn one angle. Excellent, Digit. When we connect these points and draw another segment, we do have three angles.
Did you notice that we are transforming the words that we are saying through the diagram, and my students are able to relate to the voiceover of the orator and also the diagram. So there is a connect to what we are hearing, and then there is an actual practical simulation which is taking place, which my students are following to learn the concept.
A triangle is a three-sided closed figure.
Well, here are the three angles and also three segments that meet at their endpoints. So this three-sided figure is a triangle. And when we see how it connects Bermuda, Miami, and San Juan, we can see why this area is called the Bermuda Triangle.
So you can see the explanation was very clear. With the help of visual concept, the figure was created for a triangle, and then we didn't start it with the triangle as a definition. We started from known to unknown. I am just skipping few of the portion to show you the progression into the concept.
Now, let's get the length of the sides of this triangle, Dig.
From Bermuda to Miami, the distance is about 1,600 kilometers. From Miami to San Juan, the distance is about 1,600 kilometers. And from San Juan to Bermuda, it's about 1,800 kilometers. Can you match each distance to a side of this triangle?
Again, to learning to take place, I have asked a question through the interactivity. My student will just place it here into the correct position, and only then we are able to progress to our next
That's correct.
content.
We match these distances to these sides.
Let's look at the triangle a little more closely. Using these labels, we can call this side BM, this side MS, and this side SB.
Can you complete this statement about the lengths of the sides of this triangle?
Again, here what we have seen, the progression of another level of our triangles topic for grade 5. So now we are just telling how to name the triangle. So this is my BM and this is my MS. So which is equal? Which two sides are equal? The students will again do the interactivity. So this is to retention of the content that we are explaining to the child, and the child is following.
That's correct. The lengths of these sides are equal.
This triangle has two sides that represent 1,600 kilometers, MS and BM. So they are equal.
A triangle that has two equal sides is called an isosceles triangle.
Ah, so an isosceles triangle is a type of triangle that has two equal sides.
Now, can you see here the teaching strategy that we have used? My less proficient child may not follow the words, may not follow the figure, but may follow a triangular format for explaining the type of triangle. So we have used different kind of strategies for teaching, learning to take place with my students.
Good thinking, Tej. These marks show us that this triangle has two equal sides. I wonder what we call a triangle like this though. Here, all three sides have the same lengths, so they are equal.
Please notice that the instructions are very simple with the diagrams. students are able to follow the content and retain the knowledge of the concept for longer period.
A triangle that has three equal sides is called an equilateral triangle.
That's correct, Tej. We can use these marks to show that all three sides on this equilateral triangle are equal. Okay, but can't we have a triangle where all three sides have different lengths? Yes, like that one, Tej.
A triangle that has no equal sides is called a scalene triangle.
Okay. Now, if you can just see here, my less proficient child who will not be able to remember the definitions, but with the help of a simpler table format, he will able to know that 2 equal side means isosceles, 3 equal sides means equilateral, and 0 equal sides means scalene. Now, after this, if you can see, we
Let's
also
take
have
a
a
closer look
simulation.
at these types of triangles, Digit.
Now this is a maths lab activity which is inbuilt. I can take this as a subject enrichment activity for 5 marks for my student. I can take it as a simulation for reinforcing what the teacher had said. So if I click on the vertices, I'm changing my vertices. As my vertices are changing, the units below on the table is also changing. The name of the triangle is also changing. Okay, so this is a simulation that we have for teaching of the concepts of maths. I can take this as a subject enrichment activity, and I can tell my students that they have to, over the thermocol mat, they have to create 3 vertices and they have to give me different kinds of triangles on those thermocol mats. So again, my replica is there. I am doing a demonstrative learning through the screen, and the reflective learning will take place when the students do it by themselves. At home or in classroom scenario, anything is possible. So we have seen learn, we have seen practice. Now let's come to assessments. So we have digital assessment like these.
A mystery triangle is isosceles and has a perimeter of 11 units. Use the clues to decide which of these 4 triangles is the mystery triangle.
Okay, so we have given a question. The student will have to give us the answer. He has to do the working into the notebook. Now, can you see we have a show me button here? Now, suppose my students are not able to attempt this question. I am scaffolding his learning. So let's click at show me button to see how scaffolding is done.
Okay, you have been told that a mystery triangle is isosceles and that it has a perimeter of 11 units. You have been asked to choose which of the 4 triangles A, B, C or D is the mystery triangle. An isosceles triangle is a triangle that has 2 equal sides. So, you can start by taking a look at the sides of these 4 triangles. Well, in triangle A, the length of the sides are 3 units, 4 units and 5 units. Since none of these sides have the same length, triangle A is not isosceles. So triangle A is not the mystery triangle.
Now, can you see the scaffolding that we have done? This is very important. It's a strategy we have used to solve the problem statements. Normally, my students are not able to follow the statements. They cannot decode the statement. That is why it's a problem for them. Now, here we are building a skill of decoding a problem statement through the instructions, through the questions that we have given to them.
Can you find another triangle which is not isosceles?
Okay. Now here we are not giving a direct answer to the student. We are just telling the students to click themselves. So opportunity given to the student because we have already done scaffolding. We have already done one example with them. So now my students will be able to follow the example.
That's correct. Triangle B is not isosceles. Triangle B has 3 sides of different lengths. So it is not an isosceles triangle and therefore cannot be the mystery triangle. Triangles C and D both have two equal sides, which means they are isosceles. So, one of these triangles is the mystery triangle.
So click on the triangle. So here if we see, it is 4 plus 4, 8 plus 3, 11. And this is 5 plus 5, 10 plus 3. How much is this? It is 13. So this one is my correct triangle.
Now you know that the mystery triangle has a perimeter of 11 units, and the perimeter of any figure is the sum of the lengths of its sides. Can you calculate the perimeters of triangles C and D?
Okay. So now you have noticed how learning has taken place. We have used simulations. We have used different strategies like table format to teach the concept. We have also seen how the practice is taking place. We have given subject enrichment activity which is inbuilt. The students can do the demonstrative learning and then reflect it at their home using the thermocol board. Again, in the end, we have seen that it's a practice that we have done. The practice also includes the digital assessments that we have here shown, and in this we have scaffolded the child on answering the question which may seem difficult for him. After this, we also have inbuilt assessments. So now I will go to my library of assessments. I will just take one worksheet on triangle. So this is my worksheet on triangle. So this can be used as an assessment, this can be used as an assignment, this can be used as a homework. So we have just seen the learn, practice, assess levels of a student using destination success. I hope you like this video. In case of any support required, please let us know. Thank you so much.